Now we are going to talk about impulse. Okay, so remember, actually, yep, impulse. So remember, before we talk about force measured in newtons and momentum measured in Newton seconds or kilogram meter per second. Okay, so impulse impulse is what connects force and momentum together. Okay, force and momentum are different things, but impulse connects them together. Now, um, yep. Okay, one thing you need to remember is, okay, again, impulse only occurs during a collision. Okay, only occurs during collision. So whether it's a car crash or you're hitting a basketball, when you're hitting a basketball, your hand is colliding with a basketball. So, or when we uh, throwing when I throw a rock at something, my hand practically it collides with a rock. So, impulse occurs during collision. Okay? Also, does momentum occurs only during collisions. Okay? Yep. Okay. Now, when I'm introducing impulse is has a simple I. Okay, a capital letter I for impulse. Its unit is Newton seconds or kilogram meter per seconds. Okay, so it has the same unit as momentum. Okay, but the difference is impulse is defined as the change of momentum of one object. Okay, remember the change of momentum of only one object. Okay. Now, what we learned before in the conservation of momentum, it is about the total momentum. It's a system. It's the total momentum of the whole system. However, in this case, impulse only focus on one object during the collision. Okay, that's why we call it impulse. And during a collision, we have before and after, so we need to it's defined as the change in momentum. Okay, now here is a bit it related to force. So the change of momentum and the impulse is equals to force times time. Okay, Newton times seconds. And the time here, okay, the time is defined as collision times. Okay, time during collision. Now, yep. Now let me show you an example. Okay, now have a look at this example, okay, which is the same as previous question. Okay, just before the collision, we have two objects. Okay, I name it M1 and M2. Afterwards, I have M1 and M2. Okay, travel at V1 and VA after. Okay, now, um, now before in the conservation of momentum, okay, we concentrate on the whole system. Okay. Now, in this case, when we're doing impulses, so the idea is when you want to relate force, okay, and momentum together, we're using impulse. Okay. This is for relating these two. a bridge between force and momentum, we have to use impulse. And when we use impulse, we concentrate on only we concentrate on only one object. Okay. Now I show you what I mean by this. Now, looking at this system, let me draw a line. Okay. We are going to analyze what's happened before and what's happened after. So let's look at object 1. Okay. So for M1, okay, before the collision, the momentum of M1 will be M1 times V1 before, okay, V1B, okay, which is 10 kilogram times 2, okay, which is 20 kilogram meter per second or Newton seconds. Okay. After the collision of M1, after the collision, so the momentum of M1, mass 1, object 1, after the collision will be M1 times V after 1. Okay? The velocity of object 1 after. Okay, velocity after of object 1. So if I do it, so it's 4 on 3 meters per second, oh well, here, times 10 kilogram, I have basically 13.3 kilogram meters per second or Newton seconds. Okay. Now, if we're looking at the object, okay, mass 1, okay, object 1 here. Okay. Now, the change of momentum will be the momentum after take away the momentum before. Okay. The change in something is always something after take away something before. I don't get this confused. So if you put the number in, afterwards is this much, before is this much. Okay, the change in momentum, or the which is minus 6.7 Newton seconds. Okay, and also remember the change in momentum. Well, I do it in the next row. Sorry. Weird. Okay, now just remember this. Okay, just remember this. Okay, now when we're concentrating on one object, okay, write down the impulse equation. Okay. Impulse is basically the change in momentum, which is force times the collision time. Okay. Now we know the impulse is 6.7. Okay, and we have a force times the collision time. So if you have a look at this again, okay, assume. Okay, so that's before the collision, that's after collision. Assume during the collision, okay, the collision time is, say, 2 seconds. Okay. Let's assume the collision occurred in 2 seconds. Okay. Collision time. Collision duration. Okay. Now, assume the collision duration is 2 seconds. So what we can do is we can put this number in, and you can find the force, which is 3.35 newtons minus. Okay. Now, what does this mean? Okay. This basically means, okay, during the collision, object 1, mass 1, is applied, because it's minus, is applied 3.35 Newton of force on the object 2. Then afterwards, they traveling together at this speed. Okay, so yeah, that's what it means. So again, okay, impulse, yeah, occurs during collision. Is concentrate on only object. Okay? When we use impulse, okay, mostly because we want to find the force from a collision. Okay, so I actually write it down in your notes. Okay? This is practically for finding force, okay, during a collision. Okay? And in order to do that, you need to use impulse, which concentrates on only one object. Okay? And the impulse is basically the change of momentum of only one object. Okay? Then you need a collision time. So for the same question, if I do the analyze of the second object, M2, I would get pretty much the same answer. Okay? So yeah, let me just show it to you. So before, okay, the momentum of object 2, okay, before will be the mass of object 2, okay, the mass of object 2 times its velocity. Okay, which is 5 times 0, and which is 0 Newton seconds. Okay. Afterwards, the momentum will be mass of the object 2 times the velocity after collision of object 2, which is 1.33 meters per second. So if I do it, I have 5 times 1.33. Okay. Yep. And if I type it in calculator, I have around 6.5, 6 point, approximately 6.7, approximately, okay, 6.7 newtons per second square. Sorry, newtons per second. Okay. Then, if I try to find, okay, the impulse or the change of the momentum of object B, will be momentum after take away the momentum before, which is 6.7 Newton second take away 0 Newton second, okay, which is 6.7. Okay. Then remember the equation. Impulse equals change of momentum, which is this, which is the same as force times the time. Okay. So force times time equals to 6.7 Newton seconds. Okay. Yep. Change of momentum, which is the same as the change in momentum, which is the same as the impulse. Okay, as we calculated here. Then if the collision time is 2 seconds, I have 6.7 divided by 2, which is 3.35 newtons. Okay. In this time, it's positive. Okay. So this means during the collision process, object 2 received 3.35 newtons of force.